Here we go. So today, what we're going to talk about a special group of right triangles. We're really going to get into. You guys ever heard of trigonometry?
No.
So, Liz, she definitely likes attention. So we got 7.4. We're going to talk about special right triangles. And like I said, I'm recording this. This will be on the internet.
Can I make a shout out to my
No shout outs. Right triangle, special right angle triangle. So if I take a right angle triangle and that's about almost exactly an inch, and I set it up to where I gotta measure this again. That didn't seem right. Oh, maybe it was right. And I set it up to where this line is congruent to this line. In other words, on my paper, I just made them both an inch. Okay? And you don't have to draw it exact, but just get an idea, and you could use your little hash marks. When you draw a triangle like this, and that one doesn't really look like it, but maybe if I erase this a little bit. This is the same as this. Those two lines are congruent. This angle here is going to be 45 degrees, always. So basically what we're talking about is isosceles triangle, where this is 90, then the other two remaining angles are 45. And 45 plus 45 plus 90 is 180. That's the sum of a triangle of the interior angles. What's that? Oh, in the study guide, doesn't matter. Let's just write it down this way. 90 plus 45, they're just going backwards from this, plus 45 equals 180. So they're just going backwards. Okay? So there's a ratio. If we use the Pythagorean Theorem, and I called this equal to x, if this is x, for any number x, what does this line have to be if they're congruent? X. Alright, so what I'm going to do now is, now that I know that those are both x, I could use the Pythagorean Theorem to find out this third side. So let's do that. If I say x squared plus x squared, those are the two side lengths, equals the hypotenuse. I know it's the hypotenuse because it's across from the 90-degree angle. That's going to equal some number, and we'll just put in the c squared. So it's a squared plus b squared equals c squared. Well, that is actually 2x squared, because I have 2x squareds, equals c squared. But I want to know what c is, so I take the square root of everything. Okay? Well, when I take the square root of everything, I get the square root of c squared is just c. And over here, I get the square root of 2 times x squared. I can rewrite this. I could call this the square root of 2 times the square root of x squared. Well, we'll go over the radicals and the properties in a second, if you're a little rusty. Well, what's the square root of a square? The base. So this actually becomes the square root of 2 times x squared. Or I'm sorry, not x squared, just plain old x. But x represents a number, so normally I put the number in the front. So we would rewrite it as x square root of 2 equals c. So this little segment right here is x times the square root of 2. And so I think Liz, while she was going over her study guide, she said, is that always going to be the case? But she was talking about the other triangle. Yes. So when you have a triangle, and we call this the 45-45 triangle, or just a 45 triangle, the 45-degree triangle, some teachers call it a 45-45. That's the proportions. You pick any number for x. So let's do an example of that. Let's say, we'll keep this down here. Let's say that x is equal to 2. Well, if I draw my little triangle, and I say that x is equal to 2, this is equal to 2, and this is equal to 2, and then this one has to be equal to 2 as well. So I would just say 2 times the square root of 2. Because remember, it is x, x, and then x times the square root of 2. So wherever there was an x, the only thing I did was plug in the number 2. And you can work backwards from that as well. So I'll give you a second to copy all that down. That's okay. I'm going to go over some more examples. Can I move on? No? I'll give you a second. Alright, so let's do the example that's in the book. I'm just kind of eyeballing this. I should make it a little better, but let's assume that this triangle, this is 45 degrees, this is a 90-degree angle, okay? And this is 8. Well, on a 90-degree or a right triangle, if one of the angles is 45, then the other one is 45. So this is our 45 triangle, okay? So if that's the case, then this is what we call an isosceles triangle. So if this side is 8, it has to be congruent to this side, so this equals 8. Well, remember, on our 45 triangle, this was x, this was x, this was x times the square root of 2. So what's this right here? That's right, very good. 8 times the square root of 2. That's it. I mean, that's really all you have to do. Now, let's say that you want to find that answer out as a decimal because you don't like to do the square root stuff. You would say 8 times, hit the square root button by hitting second and the square root button, 2, close the parentheses and hit equals, and that's the answer you would get. 113, or I'm sorry, 11.3. So we would say that 8 square root 2, sometimes that's pronounced 8 root 2, is approximately 11.3. Okay. Well, I want you to leave it like this. I mean, it's easier. It's one less step, right? If you know it's 8 square root of 2, just leave it like that. That's the exact answer. So let's talk about that. This is the exact answer. And this stuff right here is what we call the approximate answer. The exact is always better. Okay? The exact is always better. So, let's do another one. So, I'm going to make my 45 triangle. Just eyeballing it. You don't have to really measure it. The more you do it, the better you get at it. And in the book, we say 3 square root of 2. This is 3 square root of 2. So we notice that we have a right angle triangle with two sides that are the same. Well, right off the bat, we recognize the fact that this is going to be 45 degrees and this is going to be 45 degrees. So we already know what type of triangle it is. It's the 45. But what is x? This is, no, think about it. This is intentional. X is the side length, not the hypotenuse. The hypotenuse is across from the 90-degree angle. So if x equals the square root of 3, this right here, or I mean 3 times the square root of 2, this side, the hypotenuse, should equal x times the square root of 2. Since x equals 3 times the square root of 2, we're really going to get 3 times the square root of 2, right? We've got our x, times the square root of 2. So what's the square root of 2 times the square root of 2? Well, you could think of it like this. The square root of 2 squared. So it's just 3 times 2. Because when you square a square root, it undoes itself, and you just get 3 times 2, or 6. Let's say you went, well, we'll do that on the next problem, okay? Any questions on that so far? Not x equals 6. The side length is 6. X is, remember, this is proportional. This right here, this stuff right here, these are the proportions of this triangle. Whatever this length is going to be x times the square root of 2. Always. Always. So let's do another example. This is my 90-degree angle. Now, for example number 3, they tell us that this is 5 times the square root of 2. And this is x, and this is x, and we're told to find x. Okay? So, I recognize that these two are the same in a 90-degree angle, so as I have an isosceles triangle that has a 90-degree angle as the vertex. So I recognize that this is a 45 triangle. Okay? So, what is this side right here across from the 90-degree angle? Right, it's the hypotenuse, and it should be x times the square root of 2. What's x? 5. So, x is equal to 5. No fancy calculation. I mean, you could use the Pythagorean Theorem and crank through it, but on these particular special triangles, if you just kind of memorize it, you're good to go. All right? Let's move on to the next triangle. Can I move this off the screen? Yes? Somebody said that when I'm recording it, I sound more like, and they said I talk proper. Am I talking differently? I don't understand what they mean by that. Like before, do I usually teach like this? Yo, you know what I'm saying? You know what I mean? You know what I'm saying? Peep, yo. That's how I talk normally. So, that's all right. All right, so another type of triangle is what we call the 30, 60, 90. So 30, 60, 90. It's just a 90-degree triangle that shares a 30 and a 60 degree. That has a special type of relationship. We're just going to memorize those relationships. What this is leading up to is these two triangles are pretty much, for the most part, the foundation of trigonometry. And so we're going to start to do a little bit of trigonometry in the next two sections. So this little angle here is always 30 degrees. This big angle here is always 60 degrees. Okay? Now here's the relationship. It is 1, 2, square root of 3. All right? So let's use the Pythagorean Theorem to see how that works. Remember, the Pythagorean Theorem is c squared is equal to a squared plus b squared. What's my c? The 2. It's the hypotenuse, which is right across from the 90-degree angle. So I'm going to put 2 squared here is equal to a squared. Now, it doesn't matter what I choose for a squared. I could choose 1 or the square root of 3. So I'm going to say 1 squared plus the square root of 3 squared. Well, 2 squared is 4. 1 squared is 1. The square root of 3 squared is 3. 4 does equal 1 plus 3. So we know that's true. Now, how do I rewrite that? Well, I could think of it like this. This is 1x, 2 times x, or x times the square root of 3. So any number, remember when we did our triples, how we took the 3, 4, 5 and we multiplied them by all the same number, they worked out? That's the same concept here. If I take any number and multiply it by 1 to the square root of 3, then that'll give me the same angles on the triangle. So it's the same proportion. All right, if you're a little lost, let's do an example. I've got a triangle. When I was in college, my geometry teacher, I took geometry in college. My geometry teacher was always so precise in all of his drawings. He was always real particular about how he drew things. This is 6. This is 6. This angle here is 60. This angle here is going to be 60. And by definition, or well, by this picture, those two angles are 90 degrees. This is going to be 3, and that's going to be 3 as far as the lengths. And, because that's how it records it. If I talk real loud, it sounds too loud. It's a good question, though. Okay. So anyways, let's look at this triangle. If I look at this triangle, I'm asked to find h. Now this could be anything. This could be that you're trying to find the distance to a particular place. This could be, in the book it says that the recycling bin resembles an equilateral triangle with the lengths of 6 centimeters. What's the approximate height of the logo? So you could do the sideways too. So to find h, what am I going to do? Well, I know that this is 60. If this is 60 and this is 90, what's this angle here? 30. Well, now these two, I mean, this is an isosceles triangle, so these two triangles, remember, we proved that when you drop a line from the vertex of a triangle where it's perpendicular, that you got two congruent triangles. Well, h is the same in both of them. H equals h. That's the reflexive property. So I'm not even going to worry about that triangle to find h. So basically, and I'm going to draw this off to the side, I've got a 30-60 triangle where this is 3, this is 6, and this is something. This is h. So what is 3? Well, if I notice or if I remember, 3 is actually 1 times x. The hypotenuse, the side length across from, equals 2x. And then this one down here should be x times the square root of 3. Alright? So then what is x? If I look at this one, what's x? 3. Doesn't that make sense? Because 2 times x is going to be 2 times 3. That gives me 6. So what is h going to be? 3 times the square root of 3. So h equals 3 times the square root of 3. Okay, so Paxton asked, where am I getting the numbers from? Yeah, it's example number 4 out of the book. It's just an example. You mean the 3 and the 6? Or the 1x, 2x? Oh, we just defined it. Look up here. Look up here, girls. All of these 30-60 triangles, that's the relationship. So remember on the 40-40, or I'm sorry, the 45-45, the relationship was x, x, and the square root of 2 times x? Yeah. Now on the 30-60, 90, the relationship is 1x, 2x, and and x times the square root of 3. Well, in the picture they gave us 3, okay? That's the shortest leg. That would equal 1x. Well, 1x is really the same as x, so x equals 3. But I wrote out this extra problem, so the hypotenuse is always going to be 2x, so 6 should equal 2x. Well, what's x? 3. Since this says 3 and this says 3, I'm on the right path. I know that x equals 3. I just plug it in on the third side, and I get 3 times the square root of 3. Does that make sense? Okay.